Right. Last lesson, we were learning about displacement, velocity, and acceleration, and we're using calculus to help us. So this diagram hopefully helps to summarize it all. If we start with the displacement equation, that's an x that's kind of slidden down a little bit. We differentiate to get velocity, we differentiate again to get acceleration. If you happen to be given an acceleration equation, you will have to integrate it to find velocity. The trouble with that is you'll have an integration constant. So they'll have to give you some information for you to sub in to work out the constant so that you can integrate again and come up to the displacement. And again, you need to work out another constant when you do that. So, question 1. The velocity of a particle is given by v equals 3t squared plus 2t plus 1. If initially the particle is 2 centimeters to the left of the origin, find the displacement after 5 seconds. So that last bit is information you need to help you work out constants. But let's do the first part. My equation is a velocity equation, and I need to find a displacement equation, which means I have to integrate it. The displacement will be equal to the integral of 3t squared plus 2t plus 1, and I'm integrating with respect to time. When I integrate, I add 1 to the power, divide by the power, which means those 3's are going to cancel off. So I just want to write down here t cubed. Then let's do the same thing with the 2t. That will become t squared over 2. Again, the 2's are going to cancel off. So that will be 2 squared. And then integrating 1, we get t, and then we have plus c. All right, so we do have an equation for the displacement, but unfortunately we have that constant in there, which means that we don't know exactly what the equation is yet. So now we come to the next bit of information. It says, if initially the particle is 2 centimeters to the left. Okay, initially means what? Yes, so we'll say when t equals 0. And what does 2 centimeters to the left mean? That x equals -2, correct. So we're going to sub that into our equation. X equals -2, t is 0 and 0 squared and 0 and all those things are zeros except for the c, which means that c is equal to -2. All right, now we know the equation, complete equation, which will be x equals t cubed plus t squared plus t minus 2. But we're still not done, because there is yet another part to the question that says, find the displacement after 5 seconds. So the very last thing is that we want to sub in that time is equal to 5 to find where our particle is. Okay, so let's type in x equals 5 cubed plus 5 squared plus 5 minus 2. What did you get? 153. And that would be centimeters, just looking back to find the unit, centimeters. That's a positive, so just, thinking about it, be back to the positive side, the right-hand side of the origin. Okay, on to question 2. The acceleration of a particle is given by that lovely equation there. If the particle is initially at rest, 1 meter to the right of the origin, find its exact displacement after 9 seconds. So again, all that later information is to work out extra stuff, but we need to start with our acceleration equation, and we need to get through to a displacement, because the final thing down here is talking about displacement. Okay, so I'm going to have to integrate it the first time to get the velocity equation. Now, it's not quite in the right form for something that I'd like to integrate, so I'm going to bring my fraction up to be a t plus 1 in brackets to the power of -2. All right, integrating. 6 becomes 6t, then adding 1 to the power, you get t plus 1 to the power of negative, I erased that, to the power of -1 over -1. You also have to make sure you multiply by the derivative of the bracket, which would be a 1 on the bottom. So that usually comes down here, so that whatever is in front of the t, but there's nothing there for this one. Okay, then we have to plus c. Okay, I'll go back to them in a minute. All right, let's just tidy that up. That was a 6. So we have 6t, the 2 minuses become a plus, 2t plus 1 to the power of negative 1 plus c. All right, we almost have our velocity equation. If you're early, gentlemen, you are late. Okay, so back to our information. If the particle is initially at rest, don't mix up your velocity information, with your displacement information. Initially at rest is talking about how fast you're moving. If I'm resting, I'm not moving. Okay, so that is your velocity one. And then the other one down here, the 1 meter to the right of the origin, that's talking about displacement. So I'll come back to that one. Sorry, I highlighted the one there. That should be on the next line almost, shouldn't it? It's initially at rest, and the 1 meter to the right is going to be the displacement information. Okay, so I want the yellow information. I'm doing the velocity stuff at the moment. So I'm at the moment, initially at rest means time is 0, velocity is 0. Initially at rest. Okay, sub that in. So velocity 0. If time is 0, let's be careful. 6 times 0 is still 0. But what about that bracket? If I have 2 bracket 0, is that a plus 1 or a minus 1? It is a plus 1, good. To the power of negative 1, like that. Okay, what do I actually get for my constant? So it's a 2. That bracket actually gives you a 2. Yeah? Okay, so finding the c, let's move the 2 across to the other side. C is equal to negative 2. Yes? Yeah, good. All right. Now, v equals 6t plus 2t plus 1 to the power of negative 1. And then we have a minus 2 sitting on the end. I'm going to, or do I have enough room? I'm going to have to go down the next side as well, probably. I'll start here. To get to the displacement, integrate a second time. All right. Integrating, I will get 6t squared over 2, which will become 3t squared. I'm cancelling the 2 and the 6 straight away. Then, how do I integrate? Actually, I'll rewrite it for you because then it might look better. 2 over t plus 1. How do I integrate that? Because I couldn't do it when it was a negative 1. Why can't I do it when it's a negative 1? Because it comes to 0. And you're integrating, if this becomes a power of 0, we have a bit of a problem. Okay? So if it's a negative 1, better to have it as a fraction. And what's it going to integrate to? What kind of thing? A logarithm. So if it's a logarithm, the derivative of the bottom needs to be on the top. What's the derivative of my bottom? 1. So I need a 1 on the top. What should I do with that 2? Move it to the side. Just move it to the side. So it's going to be a 2 ln of the absolute value of t plus 1. Then we are going to integrate our minus 2, which is negative 2t plus c. All right, time to work out our second constant. What information do we have? That was the green stuff. Our particle is 1 meter to the right. That's x equals what? X equals a positive 1. X equals 1 to the right. It's positive. And that is still initially, because it's kind of in the same sentence. The particle is initially at rest and 1 meter to the right. Okay, so still when time equals 0. So I'm going to sub in when time equals 0, my displacement is equal to a positive 1. All right, in that equation that I've got, I have 1 equals 3 times 0 squared, that's 0. Then I have a 2 ln of 0 plus 1, that's 1. And then I have times 2, oh, not plus, sorry, it's a minus. Minus 2 times 0, that's still 0, not that it mattered anyway. And then I have my plus c on the end. So the zeros aren't doing anything. What is ln of 1? 0, that's also doing nothing. So c is equal to 1, because I still have the 1 on the other side. I have the 1 sneaking one over here. All right, and we have a complete equation. It is x equals 3t squared plus 2 ln of t plus 1, then minus 2t and plus 1 on the end. Are we finished? Let's go back and check. Nope. All right, one more bit. We've done that, done that. Find its exact displacement, or exact, and we know there's a logarithm in there, exact displacement after 9 seconds. So we're going to sub in that t is equal to 9. So if t equals 9, we get x equals 3 times 9 squared plus 2 ln of 9 plus 1, which is 10. Then I have minus 2 times 9, which that'll be 18, plus a 1. What can I do with that? 81 times 3. I'm going to work out all the number parts. What is it? Did you work it out already? So 3 times 9 squared minus the 2 times 9 plus 5. Did you get 230? Yep, so 230 plus 2 ln of 10. Because the 10 is positive, we can get rid of the absolute value signs. I think that's it. We're just going to leave it exact like that, so we have to go to a decimal if we go any further. What's wrong, Anthony? Did I type it in wrong? 226. 226? What did I type in? Okay, I'll believe you if you guys all did it. 226. Okay. 226. Oh, I know what I did. I thought I read my little 1 down here as a 5. That's what I did wrong. It was too squiggly. It looked wrong when I typed it in. Okay. All right, the questions are long, but it's very algebraic, right? So as long as you know the process of integrating, subbing in for constants, they're long, but hopefully not too difficult, assuming you don't do a silly thing like misreading one of your numbers. Okay? All right. Question 3. A stone is dropped from the top of a building. How far has it travelled and how fast is it going after 6 seconds? Take that gravity is equal to 9.8 meters per second squared. Okay. A stone is dropped from the top of a building. What is its speed initially? 0, starting from a stopped position. And its velocity initially is also 0, and its time is initially 0. That's a lot of good things to start with. Okay, so when time is 0, x is 0, and when time is still 0, I should also just say that v is equal to 0. Okay, so that means at the very, very start of my thing, because this stone, I don't know what it was, because the stone is completely stopped, the only thing that is happening to it at the beginning is the rate at which it's accelerating. Okay, and we're told that the acceleration is 9.8. Now, what direction is it moving? Down. So we're going to make that positive or negative? Negative? Yeah. Okay, so acceleration equals a negative 9.8 because it's accelerating downwards. Okay, now we are going to find, it says, find how far it has travelled and how fast it is going. So I need the velocity and the displacement equations. Yeah? Okay, so velocity first, obviously. We integrate the first time. Minus 9.8 with respect to time. Because it's a constant, when I integrate it, it just gets a t. And we add the c on the end. Okay, information to sub in. How far has it travelled when, well, actually, I've already written stuff at the top. Initially, time equals 0 and velocity equals 0. So I wrote it down the top. Let's sub that in. 0 equals basically 0 plus c. The first constant is equal to 0. So my velocity equation is minus 9.8 t. That's it. Okay. While we're here, we were asked to find how fast it was going. So let's sub our 6 in so we can get our velocity for this equation. So when t equals 6, my velocity is minus 9.8 times by 6, which is, okay, so it's negative, which means it's telling us the direction. So it's 58.8 meters per second down. The minus is telling us it's falling down, which makes perfect sense. It's a rock that's falling. Okay, next, we need to move on to our displacement equation. So x equals, and I want to integrate my velocity equation. Which is minus 9.8 t plus c. Okay, integrating. Because it's going to become a t squared over 2, we could divide the 9.8 by 2 to make that a negative 4.9 t squared. I'm just simplifying my integrals as I go. Then oh sorry, that shouldn't be a plus c, that was 0, remember? That's dt. Then I need to add on my constant here, so plus c. What am I subbing in this time to find this constant? 0 and 0 again. Because at time equals 0, displacement equals 0. So that means we would have 0 equals 0 plus c. The constant is still 0, which means that my equation is x equals minus 4.9 t squared. Not finished, because I need the displacement after 6 seconds still. So sub that time, we found the velocity before, now we need the displacement after 6 seconds. So that will be x equals minus 4.9 times 6 squared, and we will get an answer. I think it's 176.4. Yeah? Oh, negative, yeah, negative. Yeah, there should be a negative, shouldn't there? Yeah, negative, good. Okay, so negative just means, again, down, because it's going downwards. So you could write a conclusion in words if you wanted to. You could say the stone has fallen 176.4 metres and is travelling downwards at 58.8 metres per second. Yes? Okay. Question 4. A cricketer is standing on a lookout that projects over a valley floor that is 100 metres below him. He throws a cricket ball vertically upwards at a speed of 40 metres per second, and it falls back past him at the lookout into the valley floor below. How long does it take to fall, and with what speed does it strike the ground? And just to be difficult, we're changing gravity to be 10 metres per second. Okay? All right, you might draw a visual of this if you'd like. So here is my little guy standing on top of the cliff. He is going to throw this, what is it this time we're throwing? A cricket ball, 40 metres per second upwards, and then however high it's going to go up to whatever point, and then it's going to fall all the way down. We don't know what the total height is, but we do know that the height of the cliff is 100 metres. Okay, so let's, as always, if we're going up, it's going to be a positive direction. and that means down is going to be a negative direction. We've got two different directions happening there, so we need to be careful. What are we going to start with? We don't know. We know a velocity, but we're going to start with the acceleration again. Good. The one thing that is always constant when gravity is causing your acceleration is the gravity through that equation. So in these types of questions, it's always good to start with your acceleration. I'm going to use the dot notation. So here's my acceleration is going to be equal to -10 going down. I am going to integrate that to find the velocity. Integrate with respect to time, which will give me what? -10t and plus c. Okay, I need information. I need the velocity at a certain time. Do I know a velocity at any time to help me sub that in? Yes, I know. Which one? Oh, horizontally. We're not moving horizontally. We're only moving vertically. That's true, but we would need to know how much time it took to get there first. Yes, that's true. Gentleman at the back. Devon, Will, you need to learn this. Okay. Yes, if you did know how much time it took to go to the top, you would know that the velocity was 0 there before it dropped back down again. But the velocity that you are given is this 40 meters per second in which it is thrown upwards, which is at time is 0. That's its initial speed that you're throwing it up. So when time is 0, the velocity is, now direction right, is it a positive 40 or a negative 40? Positive because it's going up, correct. Sub it in. 40 equals -10 times 0, I'm just going to put 0, plus c, so c is equal to 40. My equation for velocity is -10t plus 40. Okay, change colour for next equation. Moving from velocity, we want to go to the displacement equation, which means integrate again. What is my integral equal to? -5t squared, good. Plus c, good. Okay, now I need information to sub in again. I need information relating to time and displacement this time. What do you think? T equals 0, it's a good place to start, but what is my displacement at t equals 0? Yeah, well, that depends. It depends where you want your origin to be. And it hasn't specified. I think we need to make our origin here because we've said it's positive going up, negative going down. So it might be easiest to put our origin right here where we started from because we're referring to where we are, positive up, negative down, right? Okay, so I'm going to make the origin where the man's standing. But if you did it from a different point, it will mean your displacement equation might be slightly different, but it will fix when you sub things in if you're putting things in with the right symbols. Yeah? Okay, so I'm going to sub in when t equals 0, that x is equal to 0, using the man as my origin. So that makes it nice and simple because 0, 0, 0, c is equal to 0 again. And my displacement equation is -5t squared plus 40t. All right, what else do I need to do? Looking back to my question. How long does it take to fall to the ground? That's talking about. So you might want to think about, these are the three main equations. That's my acceleration equation. That one was my velocity equation. And this one is my displacement equation. Because now based on those three equations, we can find other things. And what it's asking us to find is how long it takes for the stone, well no, this wasn't the stone, we've moved on from that, cricket ball to hit the ground at the bottom of that cliff. Okay? What am I going to sub in? And where am I subbing it? What information do I have? When it says how long will it take, I'm obviously after a time, right? I'm after a time that it's going to take for that, go back to my diagram, for that thing to go up and down here. Okay? The only velocity I know is here. The acceleration is going to be constant the whole way, so that's not really going to help me. The only equation that's going to help me here is the displacement. Okay? And if this is my origin, what is my displacement, Javan, when it lands? Listen, okay? Yes, thank you. Negative 100. Okay, because I made my origin here, it does need to be negative 100 because it's below. So let's sub in when, and you have done this in extension people, so you have seen this before many times with our projectile motion. This is just one direction. Okay, so we're subbing in that x is equal to minus 100 into our displacement equation, which means negative 100 equals, our displacement equation was minus 5t squared plus 40t. And I need to find t. It's a quadratic. Let's move everything to the left to make the t squared positive. So it'll be a positive 5t squared, a minus 40t, and then minus 100 equals 0. All right, what should I do next? Yes, divide the 5 to make it nicer. So we minus 8 and then minus 20 equals 0. What should I do next? Factorize first and then null factor. Yes, factorize. What times is to give negative 20 and adds to give a negative 8? Yes, positive 2, negative 10. So the solutions would be t equals negative 2 or t equals 10, but time cannot be negative. So although algebraically that solution exists for this parabola, practically speaking, it doesn't exist for our situation. So we want that time is equal to 10 seconds. Do I need to do anything else? How long does it take to fall? How long does it take to fall? So that's 10 seconds. And with what speed will it strike the ground? So what else do I need to do? Not acceleration, sorry. I don't want the, well, it is kind of a maximum velocity. I want the velocity is yes, but all I'm going to do to sub in the velocity is that t is equal to 10 into my velocity equation. Because I want the velocity to that point where it's hitting the ground, which is at this point, 10 seconds in. Because this is different to physics formulas. So those of you who are used to doing the physics formulas of working this out, these equations, you don't have to do as much of the subbing, where is it maximum, where is it a minimum, that kind of a thing. We do a little bit, but not as much, okay? All right, so sub in when t equals 10 into our velocity equation, which was minus 10 times t is 10, plus 40, and our velocity when it hits the ground is negative 60 meters per second. The negative makes sense because it's going down into the ground. So that's the direction. The 60 meters per second is how fast it's going. So you could explain those results, because if you were trying to do this question with somebody, those numbers there might not make a lot of sense. So you might want to say it takes 10 seconds to hit the ground at a speed of 60 meters per second. All right, question 5. The velocity of a particle initially at the origin, okay, so this is saying initially time is 0, at the origin x is 0, is given by v equals sine half t. Oh, trigonometry time. In units of meters and seconds. Find the displacement function. From velocity, I need to integrate the velocity to find the displacement. Okay, if you have your formula sheet there, or maybe you know, how do we integrate sine? It goes to negative cos. Good. What do I do with the half? Times it where? To the front? Front is differentiating. Yeah, you'll divide it. So the sine becomes negative cos half t, and you would divide by the half, but because it's a half on the bottom, you could flip it and bring it up to be a 2. So that would be the same as negative 2 cos of half t plus c. Okay, we have information to sub in. That was the t is 0 and x is 0. So let's sub it in. Okay, so we would get 0 equals minus 2 cos of half times 0 is just 0, plus c. What's cos of 0? 1. Okay, so we've got negative 2 here. Move the negative 2 across and it becomes a positive 2. And our displacement equation is x equals negative 2 cos of half t plus 2. Just squeeze it in. Are they too noisy and annoying? No, you're right. Question B. No, they're doing something with Mrs. Lovell. Question 2. Find the acceleration function. How do you find acceleration? Differentiate velocity. Good. So, from my... Where's my velocity? Way up here at the beginning. V equals sine half t. What does sine differentiate to? Positive cos or negative cos? Positive cos. Okay. What do I do with the half this time? Chuck it out the front. So it's going to be half cos of half t. Yes? Oh, sorry, acceleration. Put some dots on that, please. Dots for acceleration. Okay, part C. Find the values of displacement, velocity, and acceleration, all three of them, when t is equal to 2 pi. So just subbing into each of them now. Okay, where do we want to start? Displacement. Start the first one. Displacement was, if you look back to the top of your page, or that the bottom of part A, it is minus 2 cos of half times 2 pi, because t is 2 pi, plus 2. Now, half of 2 pi is just pi. If you've got your calculator in radians, you can just type it all in. But cos of pi is equal to negative 1, which means negative 2 times negative 1 is a positive 2, plus 2 is a positive 4. You can type it in your calculator. I did it in my head, but you can type it in your calculator. As long as it's in radians, just type that in. Okay? Then we want the velocity at 2 pi. So my velocity equation was the original one in the question. It was sine of half t, so it'll be sine of half times 2 pi, or half of, oh sorry, no, half and 2 cancel out, so just sine pi. Sine of pi is 0 meters per second. And then acceleration, the one from part B, is half cos, I'm just going to write pi this time, I'm sticking right at half times 2. So cos pi, and that will be equal to, has anyone done it? Negative a half meters per second squared. Okay, part D. Briefly describe the motion and sketch the displacement time graph. If we're sketching the displacement graph, it means we want to sketch the x equals minus 2 cos half t plus 2. That was my equation. If I've got to sketch that, I need to know the period and the amplitude. And also another thing has changed with the graph, hasn't it? All right, so 3 things, I guess. What is the period? Yes. So 2 pi over a half means the period is 4 pi. What is the amplitude? Good. And the other thing that I need to know to sketch it, so I've talked about that, -2, I've talked about that, is that number there. What does it do? Moves everything up 2. Good. So moved up 2. Okay, this will be fun. Let's draw it over here. The period is 4 pi. So I'm just going to go up by pi's. 1, 2, 3, 4. Pi, 2 pi, 3 pi, 4 pi. Okay, now because everything's moving up 2, you don't need much space below. So I'm going to do 1, 2, 3, 4 up here. And you'll see why. Maybe I'll do a couple down here just so I can point to them. We don't actually need those ones down below. So the letters on the axes, it's the t-axis is the horizontal, and x on the vertical is the displacement graph. Okay, so this is the cos graph. I need to work out where my graph starts. Normally my cos graph starts at 1, but the amplitude, has been increased to -2. Okay, so that means it's flipped it over and it's down here at -2. But then my graph was moved where? Up 2. So it actually comes back up to the origin. Ooh, did you stay with me for that? We are starting here at the origin. Because we are going to do a complete rotation by 4 pi, it's also going to finish on the t-axis, and we call it the x-axis, the t-axis at 0 as well, at 4 pi. Now what's it going to do in between? Right. Now normally cos starts high and comes down low, that -2 has inverted it, right? So in the middle of a cos graph, we're normally at 1. We invert it down and times it by cos graph. I'm at -1, that's right. I'm at -1, not +1. I should draw it. Here we go. I'll draw it. Here is the normal cos graph without that extra line. Okay, there's the normal cos graph. So in the middle, it is down at -1. Okay, I need to times that by 2 and invert it. So it's going to be at 2 first of all, but then I have to move it up 2 and it will be at 4. Yes. So doing all the little moves, in the middle, it is going to end up at 4. Is that okay with everybody? So in between, if you're going from 0 to 4, at pi, it's going to be at 2. That's like where my x-axis, you can kind of imagine that's moved up, and this is where it's going to be inflecting around. Okay? So at 3 pi, it will also be at 2, and it's going to come up like that. Make sure it's curving. Come down and inflect through that one like that. And that's what my displacement graph looks like. Okay, we can't avoid the describe part though. We have to describe the motion. Come on, physics people, you're good at describing. Just talk about the displacement maybe for a start. I love the word. Yes, it is oscillating between 0 and 4 for the displacement. So between x equals 0 and x equals 4 with a period of 4 pi. That's a good description, isn't it? Yeah, I think so. All right, the particle oscillates between x equals 0 and x equals 4 with period 4 pi seconds. All right, we have one more to do, but I'm going to move over here because my battery's about to die. Question 6. The acceleration of a particle is given by, now we're doing an exponential. A equals e to the negative 4t in units of meters and seconds, and the particle is initially stationary. Okay, that means time is 0, stationary means v is 0, and at the origin, which means x is 0. That's nice, isn't it? Find the velocity and displacement functions, starting with acceleration. Oh, well, from the acceleration, I'm going to find the velocity first, which means integrate the acceleration, which is e to the negative 4t dt. Integrating exponential, what does it become? So it is e to the negative 4t, but what else do I do? Yeah, so the negative 4 will come down here. I'm going to move the minus out there, though, because it looks a little bit better. And then plus c. Find the c by subbing in when t equals 0, v equals 0. So 0 equals negative e to the 4 times 0 is still 0 over 4. What does that equal? A negative quarter. But yes. Oh, yeah. Yeah. So yes, move it across the other side and it will become a positive quarter. Can we do that in one move? Sure. Sure can. So our velocity equation is e to the negative e to the negative 4t over 4 plus a quarter. Okay, we still need to find the displacement equation. So integrate a second time. Negative e to the negative 4t over 4 plus quarter dt. Okay, negative e to the negative 4t. I already have a 4 on the bottom, but when I integrate it again, another 4 is going to have to go down there. So it's going to become 16, but it was a negative 4, wasn't it? So that minus sign at the front is going to become a positive. Gone. Then the quarter becomes a t over 4, or quarter t, means the same thing, and plus c. Sub in that time is 0 and displacement is 0. We will get 0 equals e to the 0 is 1 over 16. The t over 4, that's 0 over 4, that's just 0. So plus c, so c is equal to negative 1/16. My displacement equation is e to the negative 4t over 16 plus t over 4 minus 1 over 16. So find the velocity and displacement functions. Done. This was my velocity function. This is my displacement. Question B. Find the displacement when t equals 8. That's not too bad, is it? We've already got the displacement equation. Just sub it in. X equals e to the minus 4 times 8 is negative 32 over 16 plus 8 over 4 minus 1/16. Should I do it exact? Let's leave it exact. Yeah. Or do a decimal. If you were ever in doubt, you could always go, I can get it exact to this point, and then go, or, and here's my decimal. So you've got both options there if you're ever in doubt. So to leave it exact, I'm just going to leave the e to the negative 32 over 16. Oh, okay, no, wait. I'm going to change that because I'm going to make it positive even. E to the positive 32 on the bottom. And then the 8 over 4 is 2. 2 minus 1/16 is, I've written down, thank goodness, 31 over 16. You could even, There's a common denominator there. Oh, so that e to the minus 32, let's move it back to the top, because then we have a common denominator already. Or, if I push them together, it is 16 e to the negative 32 plus 31. Okay, so a few different options there. There's a minus sign. Didn't realize that common denominator was going to come out so nicely. Part C, sketch the velocity time graph and describe briefly what happens to the velocity of the particle as it goes on. We're describing the velocity in this one. The velocity equation was v equals minus e to the minus 4t over 4 plus a quarter. Okay, to sketch that, what have we done to that poor exponential? Where is the asymptote? That's a good question to ask. A quarter. That's a good place to start. Let's draw that. So instead of being on the x-axis, our asymptote will be up here at a quarter. Okay, we did have some other information. Remember that we knew... David, can you take that outside, please? Take your computer, any stuff. You're not doing this anyway. Take your stuff and go sit down at the bench, please. When time equals 0, the velocity equals 0. This is a time and velocity graph. So that's telling me my graph is starting at the origin. That was information we knew from the question. Okay, where is my exponential going to go from there? Well, it makes sense. It's going to be coming up and approaching that asymptote. You could sub in more values if you were worried about the curve there, but that's where it's going to go. All right, we need to describe it. Sorry, what was that? Yeah. Yes, we definitely want to say that it has a velocity that is approaching a quarter. We will probably also want to mention that important point that it's starting at the origin. Yeah? So the velocity is initially 0. That's what that means, because velocity we're talking about. Velocity is initially 0 and increases to a limiting velocity of a quarter meters per second. All right. So, all right. Is there any problems with any of that? I know the questions can be long, but I think they're usually not too tricky to wrap your head around most of the time. Any questions?